So yesterday you learned how to reduce fractions and multiply and divide algebraic fractions. So today you're going to look at adding and subtracting algebraic fractions. So just like in adding regular fractions, you need a common denominator. So if I gave you 2/3 plus 2/3, you would know 2 plus 2 is 4, and when adding, the denominator stays the same. You have 4/3. So 2/3 plus 2/3 is just 4/3. So we're going to use that same principle with the algebraic fractions. So if we have x over x plus 3 plus 3 over x plus 3, we notice our denominators are already the same, so we're good to go. So we can just add our numerators, x plus 3, x plus 3, and our denominator stays the same. Now we learned yesterday that x plus 3 over x plus 3 simply reduces to 1. So our answer would be 1. Now a little bit harder, if we look at number 2 here, we notice that x minus 8 and 8 minus x are not the same. They are in fact opposites, so we need to make them the same. So I could factor out a -1. So we practiced this yesterday, but let's do it again. So I'm just going to take the first one. If I take this first one and I factor out a -1, I'm left with negative x plus 8, which is the same as 8 minus x, because it's a positive 8 and a minus x. So this is the same as that. So if I want to make this one look like this one, I could just multiply by a -1. So let's see what happens when I do that. If I just multiply this by -1, I'm left with negative x plus 8, which I notice this is the same as this. There's my negative x. There's my positive 8. So if I multiply the bottom by a -1, we know we have to multiply the top by a -1. So this fraction up here becomes negative 3x. So if I were to rewrite this problem, I'd have negative 3x over negative x plus 8 plus 2x over, and I'm just going to go ahead and reverse the order of that so they look identical. So 8 minus x is the same as negative x plus 8. So now they just look identical. So just to review, all we did is multiply our numerator and denominator by -1 because we noticed they were opposite. So you're going to do this a lot. When you notice that the denominators are opposite, simply pick one of your fractions and multiply the numerator and denominator by -1. So now let's just go back to adding this. Negative 3x plus 2x is just negative x on top. And on the bottom, it stays the same, negative x plus 8. Now ask yourself, can I reduce that at all? The answer would be no, because they share no common factors. I can't cancel those x's, so that is my answer, negative x over negative x plus 8. Okay, stepping it up a little harder even. If I look at number 3, I notice my denominators are not the same. So if I look at a simpler case, let's just look at regular numbers, and I have 1/2 plus 1/4. Well, I notice that they're not the same, but I notice that 2 goes into 4. Just like I notice here that x minus 1 goes into 2 times 2x minus 1. You can see it if you just put a times 2. Now they look identical. So just like when we find our common denominator here, and we multiply top and bottom by 2, we need to multiply our numerator here by 2. So it's the same fraction principles, same fraction procedures. So now my denominators are the same. 2 times x minus 1 and 2 times x minus 1. What I did to the bottom, I did to the top. So now I just get to add x plus 2x. You know we simplify 2 times x, which is 2x. So x plus 2x, you get 3x on the top and 2 times x minus 1 on the bottom. If you wanted to, you could put that as 2x minus 2 by distributing your 2. Either answer would be acceptable. So if you notice that one of your denominators goes into the other one, just figure out what you need to multiply it by to make it look like the other one. What you do to the bottom, you got to do to the top. Let's try the hardest level down here. So, level 4. Now, I like to always think back to the numbers. If I had 2 plus 3/4, you would find a common denominator. Well, you could just look and see that's 2 3/4. But if you wanted to add this with a common denominator, you would recognize that this is 2 over 1. And then you need to make it a denominator of 4. So you multiply top and bottom by 4. And then you can add. So let's put that over 1. And now this needs to look like this. So we're going to multiply by x plus 1. Whatever I do to the bottom, I have to do to the top. So let me rewrite that a little nicer. That first fraction, I'll put it was 2x over 1, and we multiplied the top by x plus 1, and we multiplied the bottom by x plus 1. And we did nothing to the other fraction. So this part here, 2x, 10 x plus 1, we distribute, becomes 2x squared plus 2x. So now let's just add straight across. So we know once again our denominator stays the same. Let's go ahead and put that down, because that didn't change in every single one of our problems. Our denominator stays the same. Now up top we have 2x squared plus 2 plus x minus 1. So 2x squared plus 2x plus x is going to become 2x squared plus 3x, because I had a 2x here plus x there, making 3x. And then minus 1. So the minus 1 didn't combine with anything, and the 2x squared didn't combine with anything. Now we want to ask ourselves, does this reduce? And we want to see if x plus 1 is a factor of this. So let's just try it out and see. Guess and check. Because if x plus 1 is a factor, then we can cancel it. So if this is x plus 1, this needs to be 2x, but we're multiplying to 1 at the end, and it's multiplying to a negative 1, so that means this has to be a negative 1. So let's see if this works and gives us our inner term, positive 3x. Our outer term would be plus 2x. Our inner term would be negative x. And 2x plus a negative x is 1x, not 3x. So it is not factorable. So this doesn't work. So it doesn't reduce, because this does not factor. That is our final answer. Make sure you have all of these examples written down along with the following words. So you must have a common denominator. Your denominator stays the same, and you always add or subtract your numerators. Now in these cases, I did all addition because they're a little easier. Just know that if you were subtracting, you would just subtract your numerators. So make sure you have all of these notes in your notes.